So find the 6 trigonometric functions of theta. So here's our triangle with sides 8 and 7. So we're given this triangle, we're asked to find the 6 trigonometric functions of theta. Right off the bat, we could find cosine. The cosine of theta is definitely going to be 7 over 8. But before we do that, the idea really is that we need to find the third side here. So I'm going to call this side, I don't know, x. And I know that 7 squared plus x squared should equal 8 squared. And then I'm going to solve for x. So x squared equals 8 squared is 64. 7 squared is 49, but I'm going to subtract it. So 364 minus 49. 64 minus 49 is 15. So x is going to be the square root of 15. And here, this problem doesn't mention anything about quadrants or anything like that. We're just supposed to assume that this side is a positive line. This is the square root of 15. And then we're just going to write down the 6 trig functions. Sine of theta is opposite over hypotenuse, square root of 15 over 8. Cosine of theta is adjacent over hypotenuse, which is 7 over 8. Tangent of theta is the square root of 15 over 7, sorry, which is opposite over adjacent, 15. And then the other 3 other reciprocals. So cosecant of theta is 8 over root 15, which is 8 root 15 over 15. You should rationalize your answers on the test. Secant of, so by rationalize, just to clarify, that if you have a square root in a denominator, you should do the algebra or the arithmetic to make sure that you don't anymore. So here we multiply by root 15 over root 15 to get 8 root 15 over 15. Secant of theta is 8 over 7. And cotangent of theta is 7 over root 15, which is 7 root 15 over 15. All right. So I'm just going to keep going unless you have questions. So stop me if you have a question. But let's go on to problem 2. Let's not make this rotate. Okay. This board just wants to be problematic. Question 2. Find all 6 trigonometric values of alpha equal to 11 pi over 6. So if I'm finding the 6 trig values of a particular angle, and it's a special angle, I'm looking for the quadrant and the reference angle. So I know that the quadrant here is quadrant 4 because I really have to think about which. It's always confusing to me which way I'm oriented. Do I look like I'm pointing to your right? Yes. Like this is, if I was going around the unit circle, we'd start here and we'd go around this way. Cool. So first quadrant, pi over 6. Second quadrant, 5 pi over 6. Third quadrant, 11 pi over, sorry, 7 pi over 6. Fourth quadrant, 11 pi over 6. So this angle is definitely in quadrant 4, where cosine is positive and the other 2 are negative. And we know that the reference angle is pi over 6. You can draw a triangle if you want. You can just memorize it. I know that cosine of pi over 6 is root 3 over 2. So if I was finding cosine of alpha, that would be positive root 3 over 2. If you want, you can also draw the triangle. It's perfectly fine to draw the triangle. I do want to see all your work on your exam, so definitely show as much work as you're doing. Don't just like do the work on the side and then write an answer. Show me your work. Submit your work. So that angle is pi over 6. And for this triangle, the opposite side is the small side, which is 1. The hypotenuse is 2. And the middle side is root 3. I know it's been a while since we did a special triangle, but that's a special triangle. And then so sine of this angle is going to be 1 over 2. Cosine of the angle is root 3 over 2. Oh, sine of the angle is 1 over 2, but since we're in quadrant 4, it's going to be negative 1 over 2. And tangent of the angle alpha is going to be opposite over adjacent, which is 1 over root 3, which rationalizes to root 3 over 3. But it's negative, again, because we're in quadrant form, where tangent is negative. And then the flips. Cosecant of alpha, wow, really bad at writing things sometimes. Cosecant of alpha is equal to the flip of this, so -2. Secant of alpha is equal to the flip of this, so 2 over root 3, which rationalizes as 2 times root 3 over 3. And cotangent of alpha, which I'm going to write down here because I'm out of room, is the flip of this, which is just root 3 over 1, which is just root 3, except it's negative. So it's negative root 3. All right, move on to problem 3. Which makes this tight? I always forget which way makes the word tighter. I'm tightening about it. I want to, yeah, I want that. Okay, cool. That way. I think the smoke is affecting my brain. Not really, but my eyes are tired. All right, so problem 3. If tangent of theta is equal to -4/3 and sine of theta is positive, find cosine of theta. Okay, so triangles, right? Trigonometry, triangles. So tangent of theta is opposite over adjacent, so I'm going to make the opposite side 4, the adjacent side 3. You can make it -4 over 3 or -3 or 4 over -3, but I tend, you know me, I don't like to write the negatives on my triangle. So then I'm going to find the third side, because I'm going to need the hypotenuse to figure out what cosine is. This one is probably obvious. Maybe it's a 3, 4, 5 triangle. So we know that this side, 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. 25, so x is the square root of 25, which is just 5. So then cosine of theta is either going to be positive or negative. We haven't figured out if it's positive or negative yet, but we know it's going to be adjacent over hypotenuse, which is 3 over 5. Tangent negative. If tangent is negative, we know that we're either here or here. If sine is positive, we know that we are here, because we can't be here. So we're in quadrant 2, and in quadrant 2, cosine is negative. I would also encourage you to make it obvious what your actual final answer is. Some of you have been highlighting your answers, which I think is probably for me the easiest way to see them. But if you circle or square them, that is also perfectly fine. But definitely like the ones that are highlighted, I'm like, oh, it's super easy to see what your answer is. That's awesome. But just something so I know what you mean for your answer to be will make it a little bit easier for me. If you don't do it, I will still search for your answer. So yeah. Let's look at number 4. Simplify the following to a single trigonometric term. Tangent theta times secant theta minus sine theta times tangent theta. So our answers here should be like sine or cosine or tangent or maybe secant squared, right? It should just be some trig function, maybe raised to a power. That's kind of it, or maybe 1, right? But we should just be getting one thing, not a couple of things added or subtracted together. What would I do? I would probably rewrite this as tangent is sine theta over cosine theta. Secant theta is 1 over cosine of theta. And sine theta times tangent theta is sine theta over cosine theta. So here's what I see. I see that these two things subtracted together if I multiply this part out, it's going to have a common denominator. I can think of this as sine theta over 1. And then this times this is sine squared over cosine. This is 1 over cosine, and I can put that together in one bigger fraction. So I can write this as still sine theta over cosine theta times, here my denominator, my common denominator, is cosine of theta. And my numerator is 1 minus sine times sine is sine squared theta. But we know, or we should know, that 1 minus sine squared theta is equal to cosine squared theta. So this becomes sine theta over cosine theta times cosine squared theta over cosine theta. And then cosine squared theta divided by cosine theta is just cosine times cosine over cosine. One of the cosines cancels on the top of the bottom. So you cancel a cosine here and a cosine here. So I'm left with sine theta over cosine theta times just cosine theta, or if you prefer, cosine theta over 1. And then this cosine and this cosine theta cancel out, and I just get sine theta. Now let's do the other one. I will admit, when I wrote these, I didn't think as thoroughly through them as I always do. This way, right? No, that's tired. Sorry, I was bored. Kills me sometimes. The answer to the second one is also going to be sine, which maybe isn't quite what I would normally have happen. It feels weird to make both of them come out to be the same. But yes, this next one is also going to end up being sine of theta. So I've got, let's see, cosecant of theta minus cotangent of theta times 1 plus cosine theta. And I think there's two different directions we could go. You could either first write everything in terms of sines and cosines, which is kind of my go-to. The second thing you could do, which is what I'm going to do here, is multiply it out first. So I'm actually going to I'm going to FOIL it out. So cosecant times 1 is cosecant of theta. Cosecant times cosine is going to be cosecant of theta times cosine of theta. And then minus cotangent times 1 is minus cotangent of theta. And then minus cotangent times cosine is minus cotangent theta times cosine theta. And now I'd probably go to writing things in terms of sines and cosines. This is going to be 1 over sine plus cosecant of theta is also 1 over sine theta times cosine theta. Cotangent of theta is cosine theta over sine theta. And again, cotangent is cosine theta over sine theta times cosine theta. So one thing I know, well, in fact, so we can do a little bit of simplifying. This is 1 over sine. You might just see that these cancel out, or you could write it as, so when you have a fraction times a thing, I'm really multiplying this by just the top, because this is really cosine theta over 1. 1 times cosine is cosine. Sine times 1 is sine. Minus, well, look, those are the same. If you subtract things that are the same, they cancel out. So cosine theta over sine theta minus cosine theta over sine theta cancels. And then we still have cosine theta over sine theta times cosine theta over 1, which is going to be cosine squared theta sine theta. And then we'll put these fractions together. Again, we are fortunate in that we have a common denominator already. So we have 1 minus cosine squared theta all over sine theta. And then it kind of works the same way that we did. 1 minus cosine squared is sine squared theta over sine theta. And if you don't like what I'm doing here, you can actually just write that sine squared theta means sine theta times sine theta all over sine theta. And then sine divided by sine is 1, and it just cancels out, so you're left with 1 sine theta. That's our answer. Okay. Oops. All right. Let's not spill water on my face. Okay. So let's go to the next one. If you notice on the practice test, I did give the angle sum formulas. I will give the angle sum formulas on your actual test. Not that you couldn't look them up if I didn't give them to you, but yes, if I don't give you the formula, the intention is that you don't look it up. But again, I will mention, obviously, I cannot stop you. But I'm also not a big, I don't know, I kind of go back and forth. Like clearly on the test, right, for these problems, I didn't give you the Pythagorean trig identities. I kind of just, right, we just totally, right, like here I was like, yeah, 1 minus cosine squared is sine squared. That is something I didn't give that I do kind of expect you just to know. But I couldn't stop you from looking up. So, right, it's a different world we live in. Take it with a grain of salt. So let's look at the next one. So find and simplify sine of 5 pi over 12. This one I did give the breakdown. I may or may not give you the breakdown for both of them on your actual test. I haven't decided. But I'm going to write this as sine of pi over, how did I write it? Pi over 3 plus pi over 4. And then we're just going to throw the formula at it. So sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. That's going to be sine of the first angle times cosine of the second angle. If it's a plus here, it's a plus here for the sine formula. Cosine of the first angle times sine of the first angle. And then you just have to make sure you remember which one's which. Sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is 1/2. And then cosine of pi over 4 and sine of pi over 4 are both the square root of 2 over 2. Whenever you do an angle sum formula like this, you're always going to get a root 3 over 2 in one of the two things added together and a 1/2 in the other one. And then both of them will also have a root 2 over 2. It's just that some of the signs might be negative instead of all being positive. But it's always going to look like this. And then simplifying, root 3 times root 2 is the square root of 6. 2 times 2 is 4. Plus 1 times root 2 is root 2. And 2 times 2 is 4. And since these fractions have the same denominator, we put them together as one fraction. And we get the square root of 6 plus the square root of 2 all over 4. And that's our final answer. I'll try not to kill this blue pen. Problem is I get a pen that's good and I just keep using it until it dies, whereas if I was a little more, if I spaced it out, it would probably last longer. Well, that's the way to go.
I have a question.
Yeah.
So for the other one, like the last one, for that one, we don't have to square root the bottom?
No, so what I think you're thinking of, and I definitely saw some people do this on the homework, is they made the bottom a 2, they took the square root of 4. That's not what's happening here. I think you're thinking of the half angle formula, where we end up with like a square root of 1 minus root 2 over 2 all over 2, and then we multiply by 2 over 2, and we have a 4 inside the square root of the denominator. We will definitely see that when we look at the next problem, which is when we look at, maybe I'll skip the problem 7 after this so that we can see the difference.
As well.
What's that?
So you don't find whether it's negative or positive. Do you do it based off the pi over 3?
Yeah. So for the angle sum formula, this one here, you totally don't have to make any decisions. It's these values. These values are totally based off the fact that this angle pi over 3 is in quadrant 1. And this angle pi over 4 is in quadrant 1.
So the 5 pi over 12, you don't have to do it based off that one. Rather the sine? Okay.
Right. So the thing I think you're thinking of is when you have something pi over 8, which we'll definitely look at shortly here. But yeah, for these ones, it's always going to look like something root 6, something root 2, all over 4. I'm trying to stay on the other side. Okay. So I think I'm doing a bad job, but it's all right. So now the next question asks us to use the angle sum formula for cosine of 17 pi over 12. And in this problem, it's not given to us how to break it up. There are definitely multiple ways of breaking it up. I'm going to go with what I feel like is the simplest. So I'm going to try and find a way to add up the 17 pi over 12 where both fractions reduce. And I'm going to start with the smallest thing that reduces, 2 pi over 12. I'm going to see if the rest of it also reduces. It does. So I'm going to do this as cosine of 2 pi over 12 plus 15 pi over 12. But there are other choices that would be equally valid. 3 pi over 12 and 14 pi over 12 would also be a choice that works because both of those reduce as well. 4 pi over 12 and 13 pi over 12 would not, because 13 pi over 12 doesn't reduce. 5 pi and 12 pi also doesn't work because 5 pi doesn't reduce. So there are some choices, but there are a lot of choices that won't work because they don't all reduce. So definitely pick fractions that reduce and then rewrite it as cosine of 2 pi over 12 is pi over 6 plus 15 pi over 12 is 5 pi over 4. And now we're going to use the angle sum formula for cosine. Oh, I wrote it wrong in the notes. I'm so sorry. Oh, it's terrible. I definitely wrote my answer right when I was writing my answers, but I wrote cosine alpha, cosine beta plus sine alpha, sine beta, and that is wrong. So I will definitely, so here's what I would say. If I accidentally write something wrong on the test, which I don't plan to do, but could happen, you have a few options. You can either, one, email me right away as soon as you see it. If you think it's a mistake, I will definitely look at it and respond that it's either A, it's a mistake and I'll fix it, or B, it's not a mistake and you should think about this. 2, if you don't realize, you could just use the formula as is and I'd be like, oh, I made a mistake. I'm going to grade it like it's correct, even though I made an error. Or 3, you could write down what you know is the correct formula and just do it that way. But I would say, I would certainly appreciate it the most. If you think I've made a mistake, let me know right away and I will try to fix it right away. So the formula here should actually be cosine alpha. In fact, let me write it down. Sure. It's cosine of alpha plus beta equals cosine alpha times cosine beta minus sine alpha times sine beta. Sorry about that. Everyone makes mistakes. So this is going to be cosine of pi over 6 times cosine of 5 pi over 4 minus sine of pi over 6 times sine of pi over 4. Sorry, sine of 5 pi over 4. And for this one, we have to pay a little bit more attention because the previous question, right, both the angles pi over 3 and pi over 4 were in quadrant 1. Here are both of our angles are not in quadrant 1. Pi over 6 is in quadrant 1, but 5 pi over 4 is in quadrant 3, where both sine and cosine are negative. So here we're going to get cosine of pi over 6 is root 3 over 2. Cosine of 5 pi over 4, well, I know the cosine of pi over 4 is root 2 over 2. So cosine of 5 pi over 4 being in quadrant 3 means it's going to be negative root 2 over 2. Sine of pi over 6 is 1/2. And sine of 5 pi over 4, again, it's a root 2 over 2. But since it's in quadrant 3, where sine is also negative, it's actually a times a negative root 2 over 2. And then I just multiply it out. Root 3 times root 2 is root 6, but there's a negative, so it's actually going to be negative root 6 over 2 times 2 is 4. Minus a minus is going to be plus 1 times root 2 is root 2. 2 times 2 is 4. So we could write this as either negative root 6 plus root 2 all over 4. Or if one of them is negative, I usually prefer to put that one second. So I would personally prefer to write it as the square root of 2 minus the square root of 6 all over 4. Either way would be perfectly correct here. But again, definitely for an angle sum or an angle difference, you're going to have a root 2 and a root 6 in the numerator and a 4, not a 2, in the denominator. Let me skip. I'm going to skip question 6. I'm going to go to question 7 just so we can see the difference. And then I'll back up to question 6. Come on. Yeah, what do you... One of these days I will figure out how to like do this thing right. I think, and then the problem is one side gets tight either way. Yeah, that's the problem. It's no matter which way you flip it, one side is going to get tight. So now let's look at this one, problem 7, which is to use the half angle formulas to find the following. So let's do first sine of 3 pi over 8. So I will remind you there's a slightly different formula for sine versus cosine. The sine formula has a minus in it. The cosine formula has a plus, like inside the root. So sine of theta is equal to plus or minus the square root of 1 minus cosine of 2 times theta, or the angle here, theta is 3 pi over 8 over 2. So then this is where we have to decide. Is it actually plus or is it actually minus? Well, 3 pi over 8 is definitely in quadrant 1, right? It's less than 4 pi over 8, which is pi over 2. So we're in quadrant 1, and if we're in quadrant 1, sine and cosine, but really sine is positive. So sine of this angle in quadrant 1 is going to be positive. That's the first decision we have to make. Is the overall thing positive or negative? It's totally based on whether it's sine or cosine here, and what quadrant this angle is in. And then, so it's positive. You don't have to write the positive, but I like to. Square root of 1 minus cosine of. So 2 times 3 pi over 8 is going to be 3 pi over 4. Because the 2 and the 8 will cancel out and you'll leave a 4 behind. So now I know that cosine of 3 pi over 4 is something with a root 2 over 2. It's either positive root 2 over 2 or negative root 2 over 2. In this case, since 3 pi over 4 is in quadrant 2, we know that cosine is negative. So I know that this is going to be plus the square root of 1 minus negative root 2 over 2, all over 2, right? This cosine of 3 pi over 4 is negative root 2 over 2, but it's minus negative root 2 over 2. This ends up being the square root of 1 plus root 2 over 2, all over 2. And then the rest of it is just simplifying. So we have to multiply the top and bottom by 2 over 2. The 2 on the top distributes. The 2 on the bottom just multiplies the 2 there. So I end up with plus square root of 2 times 1 is 2. 2 times the square root of 2 over 2. The 2's cancel and you just get the square root of 2. All over 2 times 2 is 4. And then this is where we say, oh, but the square root of 4 is just 2. So we rewrite this as 2 on the bottom, not in the square root, and the square root of 2 plus root 2 on top. So this is what I think someone was asking about when they're saying, don't we have a 2 on the bottom? That's when you have the half angle formula. That's when you end up with a 2 on the bottom. For the angle sum or angle difference formulas, you always end up with a root 6 and a root 2 and a 4 on the bottom. Okay. So the answers to the half angle formulas should also all pretty much look the same. They might just differ by a plus or a minus here and there. So let's look at the other one that's on there. How much time do I have left? Let's not. I always think I'm going to get through everything, and then I don't. So cosine of 7 pi over 8 is going to be, again, plus or minus the square root of 1 plus cosine of 2 times the angle 7 pi over 8. all over 2. Here, 7 pi over 8 is just a little bit less than pi. So we're in quadrant 2. If it was sine of 7 pi over 8, I'd be picking the positive because sine is positive in quadrant 2. But since it's cosine of 7 pi over 8, we're picking the negative because cosine is negative in quadrant 2. So it's going to end up being negative square root of 1 plus cosine of 2 times 7 pi over 8 is 7 pi over 4. All over 2. Cosine of 7 pi over 4 is positive root 2 over 2 because 7 pi over 4 is in quadrant 4 and cosine is positive in quadrant 4. So it's negative square root of 1 plus positive root 2 over 2 all over 2. And then we do the same thing. So we multiply the top and bottom by 2. So we get negative root, this times 2 is 2. This times 2 is just root 2. And the bottom times 2 is 4. And then the square root of 4 is 2. And the numerator is just the square root of 2 plus root 2. So these half angle ones always simplify in the same sort of way. Okay. Let's go back to 6. Whoa, I'm gonna spin it all around. Let's see here, 6. Whoops. Given sine of theta is equal to 3/4 and cosine of theta is negative, find sine of 2 theta, cosine of 2 theta, and the quadrant 2 theta is in. So sine of 2 theta is equal to 2 sine theta cosine theta. I know what sine theta is. I don't know what cosine theta is. So the thing here that's always going to be true when I ask you this kind of question is you're going to have to draw a triangle to find out what the other trig function of theta is. So sine of theta is 3/4, opposite of hypotenuse. This is not a 3, 4, 5 triangle, right? It's only a 3, 4, 5 if the hypotenuse is 5. So I have to find the other side. X squared plus 3 squared equals 4 squared. X squared equals 16 minus 9. X equals the square root of 16 minus 9 is 7. So this adjacent side is square root of 7. So sine of 2 theta is equal to 2 times sine of theta is 3/4. Cosine of theta is adjacent over hypotenuse, which is root 7/4. But cosine is negative, so it's negative. And then I would probably say that 2 and 4 cancel and give me a 2 down there. So I really got 3/2 times negative root 7/4, which is just going to be negative 3 root 7 on top, 2 times 4 on the bottom. So there's sine of 2 theta. For cosine of 2 theta, personally, I prefer to do it as cosine squared theta minus sine squared theta. You might want to do something different, that is fine. I'm going to do it this way and I'll do it another way. So here, cosine of theta is negative root 7/4. So it's negative root 7/4 squared. Sine of theta is 3/4, so that's 3/4 squared. So I end up with a negative number squared is always positive. Root 7 squared is 7. 4 squared is 16. Minus 3 squared is 9. 4 squared is 16. So I get negative 2/16, which is negative 1/8. Finally, I'm just going to say the answer to the third part. Since sine of 2 theta is negative and cosine of 2 theta is also negative, the angle 2 theta has to be in which quadrant? quadrant 3. That's where sine and cosine are both negative. So 2 theta is in quadrant 3 because sine 2 theta is negative and cosine 2, right? You should definitely, when you answer that question on your test, if there's one like it, you need to give the reasoning why it's in the quadrant. It can be as simple as writing sine of 2 theta less than 0, cosine 2 theta less than 0. Okay. Graphing stuff. Let's see here. So write the equation of a cosine function with an amplitude of 3, a reflection across the x-axis, and a period of pi. So I'm going to start the period first. So the period, so here's what I'm kind of thinking. I know our equation usually looks something like a times sine of bx plus d, where the absolute value of a is the amplitude. This is going to help us with the period. I mean, that's not, I wouldn't say b is equal to the period. Really, the period is 2 pi over b, and d is the vertical shift. So here, I want the period to be pi. So I'm going to set pi equal to 2 pi over b. And you might just see from this part here that b has to be 2, because 2 pi divided by 2 is pi. Or you can do some algebra. You can multiply both sides by b. B times pi equals 2 times pi, and then divide both sides by pi. So that b equals 2 pi over pi, which is 2. The amplitude needs to be 3, which means the coefficient out in front could be 3 or negative 3. But we know it needs to be negative 3 because we need a vertical flip as well. So our equation is actually going to be y equal to negative 3 times sine of 2x plus 0, right? Because it didn't ask for any vertical shift. You could also give it a vertical shift, I guess, if you want to, right? It doesn't say you couldn't have a vertical shift. So you could throw one in there if you want to make it more complex. I don't think that's really necessary here. And then we have to graph it. Let's see here. So graphing it, we're doing y equal to negative 3 sine of x plus, negative 3 sine of 2x. So an amplitude of 3, we don't have a vertical shift, so we know our middle line is the x-axis. We're going up 3 and down 3. On your y-axis, you really just want the values that are the top, the bottom, and the middle. And then on the x-axis, we want the 5 important points. Well, the first one's the origin, or the x equals 0. And then we're going to take our period, which is 2 pi over 2, which is pi, and we're going to divide that by 4, which is pi over 4. So our important points are 0, and then 0 plus pi over 4 is pi over 4. And then pi over 4 plus another pi over 4 is 2 pi over 4. And then 2 pi over 4 plus another pi over 4 is 3 pi over 4. And then 3 pi over 4 plus another pi over 4 is 4 pi over 4, which is pi. You can write them on the x-axis. You can write them over here. They should be equally spaced out, right? They're all exactly a quarter of a period, so they should all have the same length. And then we're going to draw a sine. So sine, I think I might have drawn this one when I was writing the answers. I'll have to redo it and double check. Sine, I definitely drew. I didn't draw at all. Oh, ha. It's because they asked for a cosine function, right? It says cosine, not sine. So it should actually, luckily that's easy to fix. Cosine. So cosine would usually start high and then go middle and then low and then middle and then high. But since it's flipped over, it's going to start low. You can also plug in 0. If you plug in 0, cosine of 0 is 1, and negative 3 times 1 gives you negative 3. And then it's always just going middle, extreme. middle, extreme, middle, high, middle, low, middle, high, middle, low. Right? It's always that pattern, whether it's sine or cosine. So low, middle, high, middle, low. You should always end at the same elevation you started at, and you shouldn't get there until the end. Meaning if you start low, you should only get back to being low at the very end. There we go. Time. How much more? I want to say more about the other stuff. Let's see here. So what I think I want to do is, I think I want to go straight through and cover all of this, even though I know I'll go over. If you have to leave, that's fine. But I want to do it all so then I can post the recording of it all in case you want to look at it later. So you are welcome all to leave at 2:20 or whenever. You're also welcome to stick around while I finish off the rest of this. There's not a lot more, but there's enough more that I know I'm probably going to go to like 2:30 instead of 2:20. So please, if you got to go, I totally get it. But if you can stick around, I certainly think you should. Sorry, let's see here. So now we're going to graph the next one. So we're going to graph y equal to 2 times sine of 2x over 3. I will also say I will definitely be sure as soon as I'm done with office hours at 3:30, I'll make sure I'll start compiling this right away and make sure I get it posted right away. So that if you do want to see the rest of it and you're not here, you can see the rest of it. Okay, same kind of stuff. Amplitude is 2. The vertical shift is going to be 1. And the period is going to be 2 pi divided by the coefficient, which is 2/3. When you divide by a fraction, you multiply by its flip or reciprocal. 2 pi times 3/2 is 2 pi over 1 times 3 over 2, which is 6 pi over 2, which is 3 pi. And so my vertical shift is 1, so I'm going up 1. So that's my new middle. And then my amplitude's 2, so I'm going to be going 2 above it, all the way up to 3, and 1, 2 below it, down to -1. I don't really care about any other y values except for the top, the middle, and the bottom. And then I should find the x values. So I know they're going to be equally spaced out, a quarter of a period each, but I still also want them. So 1/4 of a period is just 1/4 times the period, which is just 3 pi over 4. So my first point is 0. My next point is 0 plus 3 pi over 4. My next point is 3 pi over 4 plus 3 pi over 4, which is 6 pi over 4. My next point is 6 pi over 4 plus another 3 pi over 4, which is 9 pi over 4. And my last point is 9 pi over 4 plus another 3 pi over 4, which is 12 pi over 4, which reduces to 3 pi. And you don't have to write them on the graph, but you do need to write them somewhere. And then sine. Sine starts at the middle. Sine starts at the middle, and then if the next point goes high, the next point back to the middle, right? If you're going high, the next thing is always back to the middle. If you're going low, the next thing is always back to the middle. So if you're not at the middle, you're going back to the middle. And if you're at the middle, you're going to the extreme you weren't at. So if I went middle, high, middle, I have to go low because I can't go back to high. I have to go to the other one. And then back to the middle. Looks pretty nice. Pretty pleased with that. So that's how that one looks. All right. My alarm is going to go off. It will not scare me, probably. So we've only got a couple more things on here, so it shouldn't take too long. But I do want, gosh, I keep looking for my paper. It's on the computer. Oh, my alarm's going off in another room. Sorry, let me go turn off my phone real quick. I guess I didn't grab it. My wife was out like that to keep going off. Sorry about that. I got it. Okay, sorry. Left my phone in the other room. Happens sometimes. All right, we just have a couple things left. It should be probably 5 minutes at the most, maybe. So write out in words what the following means and then state the answer. So what I'm really looking for, if you're finding the inverse sine of root 2 over 2, I want you to know that it means find the angle whose sine is root 2 over 2. Those are the words, something like that. It doesn't have to be exactly that, but something like that. You can even be more specific. Find the angle in quadrant 1 or quadrant 4 for sine, whose sine is root 2 over 2. So since it's positive, we know we're looking at quadrant 1, and the inverse sine of root 2 over 2 is going to be pi over 4. Because that's the angle that if you took sine of it, you would get root 2 over 2. Yeah, probably could have fit both of those on there, but I didn't plan. Okay, let's do the next one. Inverse cosine of negative root 3 over 2. Again, this just means the same thing, the same sort of thing. Right? The words would be find, or just the angle. Right? Angle is what's really important there. I'm going to leave some space. Whose cosine is negative root 3 over 2. And for inverse cosine, it's the angle in which quadrant? Quadrant 1 or quadrant 2. So since in this particular example, we want cosine to end up being negative root 3 over 2, we have to have an angle that's in quadrant 2. So the inverse cosine of negative root 3 over 2 is 5 pi over 6. Because cosine of 5 pi over 6 is equal to negative root 3 over 2. Okay. But I do think, I think I will probably ask you a question like that where I want you to write out the meaning, because I do think it's important that you understand the meaning of the inverse trig function. It comes up often enough that it's important to understand what you're looking for. Okay, just a couple more. Again, if you gotta go, totally understand. Please do feel free to leave. No judgment if you gotta go. Well, let's do number 10, and then we'll do 11. Then we'll be done. So number 10 is finding the sine of the inverse cosine of negative 3/5. And again, for this kind of question, we have to draw a triangle. So inverse cosine of negative 3/5 is an angle. So it's an angle such that cosine of this angle should equal negative 3/5. Again, you know I'm not going to write the negative. We know this other side is going to be 4, because again, this is a 3, 4, 5 triangle. So sine of this angle should equal 4/5. But let me ask, is it positive or negative? Well, we know inverse cosine. We know that theta is in quadrant 1 or quadrant 2. And regardless here, sine of an angle in quadrant 1 or sine of an angle in quadrant 2 is positive either way. So we really don't have to think too much about which quadrant it's in. We know that sine will have to be positive. Okay, let's do the other one. I kind of must have changed the other one up to have it be like something slightly different, but oh well. I didn't mean for both of them to really have inverse cosine in them, but that's what I ended up writing. So let's do tangent of inverse cosine of negative root 33 over 7. Again, this thing I've written, the inside part here, this is an angle. Let's call it theta. And theta is in quadrant 1 or quadrant 2. And here it is going to matter what quadrant we're in for tangent, because tangent's positive in quadrant 1 and negative in quadrant 2. So again, this is an angle that if I took cosine of the angle, I would get negative root 33 over 7. But if cosine of the angle is negative, I had to be in which quadrant? Had to be in quadrant 2. Basically, if it's inverse trig function of a negative, you know you're not in quadrant 1. So then draw the triangle. The adjacent side is root 33. Is that what I really wrote? Okay, I guess it is. The opposite side is 7. Sorry, the hypotenuse side is 7. And then we're going to find this with the Pythagorean Theorem. So square root of 33 squared plus x squared equals 7 squared. 33 plus x squared equals 49. 49 minus 33 is 16. So x equals the square root of 16, which is 4. So then, I'm just going to write it up here since I'm kind of out of room. Tangent of this angle, right? This angle is that angle. It is opposite over adjacent, which is 4 over root 33. But it's negative because our angle is in quadrant 2. And then we should also rationalize it as negative 4 root 33. Okay. Last page of questions. There are 3 of them. They won't be too terrible. Probably finish, maybe slightly longer than 2:30, but we'll finish very soon here. Okay, so let's do these. Yes. Find all solutions to the following trigonometric equations for x between 0 and 2 pi. So the first one is 1 plus tangent of x. This one's pretty straightforward. We're going to isolate our trig function. So we're going to say tangent of x is equal to negative 1. And then we know that tangent is equal to positive 1 for the reference angle of x equal to pi over 4. But we need to be in quadrants 2 and quadrants 4 for tangent to be negative 1. So we need, in quadrant 2, the angle with pi over 4 as reference angle is going to be 3 pi over 4. And in quadrant 4, the angle with pi over 4 as reference angle is going to be 7 pi over 4. So those are our values for x. And if you want, you can always plug those back in and actually check and see if they're right. You don't have to check them to see if they're right, but you could if you wanted to. All right, 4 sine squared of x is equal to 1. This is one of those equations where I'm pretty sure I'm going to get an answer in every quadrant. So divide both sides by 4. And then take the square root of both sides. Now, if I take the square root of both sides, I have to say that sine of x can be positive or negative, the square root of 1/4. But what's the square root of 1/4? It's 1/2. If you're not getting values here that look normal, I've probably made a mistake. Or you've made a mistake. One of us has made a mistake probably. Right? If you're getting like sine of x is equal to 2/3, you're like, what's going on? That shouldn't be happening. So you should get values that make sense. So sine of x equals 1/2. You know, the reference angle for that is pi over 6. And then we get an answer in each quadrant because sine is positive in quadrants 1 and 2, and sine is negative in quadrants 3 and 4. So my angles are going to be all of the angles that have pi over 6 as reference angle. So pi over 6, 5 pi over 6 in quadrant 2, 7 pi over 6 in quadrant 3, and 11 pi over 6 in quadrant 4. Wow, that looks messy. Let's try that again. Okay. Yeah, okay, whatever. All right, last one, and then you're already free to go, but then I'll be done talking. You can actually really be free to go. You're always free to go. I mean, technically your attendance is required by the STEP program, but yes. But once class is over at 2:20, you are definitely free to go if you want to. So last one, cosine squared of x plus cosine x equals 0. So this one is one kind of similar to the last one we did yesterday, where you don't want to like divide by cosine of x. You just want to factor. So each of these I can factor or divide out a cosine. Cosine squared divided by cosine is going to leave me with a cosine. And cosine divided by cosine is going to leave me with a 1. And I'm not dividing it out because I'm not just making it go away. I'm not dividing both sides by cosine. I'm just pulling a cosine out. And then we're going to use the zero product principle and say, well, if this times this is equal to 0, then either cosine x equals 0 or cosine x plus 1 equals 0. So where does cosine equal 0? Left, top, right, bottom.
Top and bottom?
Yeah, exactly. Which is x equal to pi over 2. And 3 pi over 2. And then this one's going to give us cosine x equals -1, which is the top, left. I'm all screwed up with my directions. Sorry. Top,
Left.
right. Sorry, fucking hell. Yeah. It's the left, which is pi. Draw a unit circle. That'll be way better than me trying to point every which way. So I get 3 answers here. Pi over 2, 3 pi over 2, and pi.